Mr. Horton's first online math lesson ever. Let's try this out. I got my whiteboard, so you got to read my terrible handwriting. I got Mr. Westbrook here staring you down with those intense looks. And I got my justify and generalize posters. And today we are really going to focus on generalizing what a percent is. Now, a percent is a ratio. And we've been studying ratios all year, so it's not something too new for you. So imagine I've got this ratio, and I'm going to write the word percent up here. And we're going to break this word down. Percent. The first part is per. Now, per tells us that a percent is kind of like a division problem. And a division problem is a fraction, and that's why the symbol for division looks like a fraction with a numerator and a denominator. Now, this line right here, this is our per from the percent. Something per something. Well, what goes on the bottom here? That's the second part of our word. This word, cent, C-E-N-T, means 100. You might see it like in a dollar, it has 100 cents make up the dollar. All right? That's just an idea, helping you out with this. So on the bottom, we basically got 100. Something per 100 is a percent. All right, Mr. Horton, how does that work? Well, let's say that I shoot 100 baskets out at the school. And you guys know how amazing I am at shooting. That's how I got the nickname Airball Eric Horton. And let's say I made 12 of those shots. And I shot 100. I could say this number as 12%. I made 12% of the shots. All right. That's our first basics. Now, let's take it to another level. So let's say I'm going to create a problem here, and I'm going to talk about all of the kids at the school in 6th grade. And in 6th grade, we're going to say there are 60 students. And out of these 60 students, some of them really like tacos. And some of them really like pizza. So we're going to say, what if 24 love tacos? Now I'm going to ask a question. This would be a good time to get a piece of paper out, copy this stuff down, and practice some of these steps. The question is, if 24 kids love tacos, what percent of the total kids love tacos? What percent love tacos? Now notice I drew this little symbol here. This symbol that's like a zero kind of with a line and a zero. This is the percent symbol. What happens if I just turn that symbol a little bit? Actually, I want to turn it the other way. Turn it just a little bit. And you'll notice it's a fraction. The symbol for percent comes from the number per 100. It actually used to be written a little bit different to where the denominator on the bottom actually said 100 on the bottom in this little tiny subscript. So I want to know what percent love tacos. Well, the first thing I can do is I can rewrite this problem as a fraction. On the bottom, I'm going to write the total, and on the top, I'm going to write the number that I'm thinking of. Well, let's rewrite this with the numbers. So I'm going to give you about 10 seconds. Think about it. What am I going to put on the bottom? Which of these two numbers represents the total? If you're thinking 60, bam, you got it. 60 on the bottom. And therefore, the number I'm thinking about, or the number of kids that love tacos, would go right here. So I've got 24 over 60. We've got a problem, though. Percent needs to be something over 100. Now I'm stuck right here at this 24 over 60. What could I do with that? What type of thing, mathematically, what type of expression or function could I do to alter these numbers in a way that's going to help me understand how it's 100%. Well, let's look at this in a couple different ways. So I've got my 24 over 60. I could create this in a table. And if I made this table, on one side, I'm going to put 24, and the other side, I'm going to put 60. Now, this is a ratio. So whatever I do to one side, I have to do to the other side, because the ratio has to stay locked in. So we've got our 24 over 60. And I'm thinking, I've got to somehow get this to 100 over here. But I can't multiply 60 by anything to get to 100. But I could go backwards before I go forwards. What if I thought about both of these numbers and I went all the way back to the first weeks of school and I thought about greatest common factor? Well, what's the greatest common factor between 24 and 60? Or what's a common factor? Because the greatest common factor is actually 12, and I don't want to use 12. I'm thinking 6, and I could divide both of these numbers by 6, and when I do 60 divided by 6, I get 10. And when I do 24 divided by 6, I get 4. Aha! Now we've got a clue, because here I'm at 10, I can get to 100 from 10. And what do I multiply 10 by to get to 100? I multiply 10 by 10. And because it's a ratio, I have to do the same thing to both sides. So here, I'm going to multiply 4 by 10, and I'm going to get 40. 40 per 100, or 40%. Maybe you're thinking, oh, Mr. Horton, tables aren't for me. I don't want to do a table. Help me out with something else. I'm not making sense of it. Here's another tool. This one's actually my favorite. This one's called a percent bar. So I want you to draw this rectangle right now on your piece of paper. And in this rectangle, I want you to identify 100% is right here. Now, we didn't know what 100% was in this problem. No, wait, we did. We did. It was 60. And we knew 24 kids, but we didn't know what percent that was. So we had to think about the same idea. How would I go backwards with this percent bar? How would I go to a number here? Well, what if I divide 100% by 10, and that would give me 10%. I divide 60 by 10. Remember, I have to do the same thing to both numbers because it's a ratio. 60 divided by 10 would give me 6. So I know that 6 and 10 is part of my locked-in ratio. Well, now, how do I get to 24? I have to times it by 4. I have to times 10 by 4, and that gives me my answer. 10 times 4 is 40. 40 and 24 are locked in on the same ratio program. Other numbers that could be on here, I could go 6 and 12. If I did 12 here, this would be 20. What if I want to know how many 30 was. Well, 6 times 5 is 30, so 10 times 5 is 50, 50%. Once I build this percent bar, I can figure out any of the numbers. Well, maybe you're the person that's thinking, all right, I don't want to draw a picture, Mr. Horton. I don't want to make a table, Mr. Horton. I just want to know the algorithm. How can I do it? Because I'm a numbers guy and I just want to do the numbers. Well, I told you at the very beginning. It's a fraction. And all fractions are division problems. So we go back to this division problem here, and this tells me 24 divided by 60. So I can create the problem and rewrite it as 24 and 60. Well, we've got a problem. 60 can't go into 24. It's too big. We put a 0 here, because 60 can't go to 24. And then we're going to add a decimal point, and I'm going to bring that decimal point up to the top, and I'm going to add a 0. And now I'm thinking, how many times could 60 go into 240? All right, 60 and 60 is 120. We take 120 and I add another 60 and I'm at 180. I take 180 and I add 60 and I'm at 240. I have 160, 2 60s, 3 60s, 4 60s. 4 times 60 is 240. My percent is 40%. So I can find it in any of these 3 ways. Which one do you like best? I challenge you to try it using all 3. The more ways that you can solve it mathematically, the better you're going to know the math. This is just one way to do percents. Check it out. I got an assignment for you. Go check out your Google Classroom. Check out your learning grid. See what you can do to attack this on your own. If you have any questions, send me an email, but try it on your own first. Try it on your phone first and don't give up. All right? Thanks, guys.